Aquatic systems are so diverse. You have everything from marine systems or oceans to freshwater systems. I'll try to touch a bit on all of those. So we'll talk about some profiles of some mammals and some fish, and even aquatic animals, even that category, it's a little bit fuzzy, right? There are some animals that never leave the water, and there's quite a number of really interesting animals that are transients, right? That are sort of moving in between. So we'll talk about some examples of all of those, and what some things that are happening in aquatic places around us. So when you visit them, it's kind of, I find it really fun to sort of think about what's happening in these presumably frozen places. So we're going to end up talking a bit about water today. An aquatic system is a system that's fundamentally, based in water. So, we're called the blue planet for a reason, right? Water, I could extol its many awesome virtues for quite some time. Almost 3/4 of our surface is covered in water. We're at 71%. The vast majority of that water located in the oceans. And something to be really sort of, keep your eye on in the next few decades is sort of how, fresh water becomes even more of a precious resource. And, all fresh water is not created equal, of course, right? We need high quality fresh water that's not contaminated by any number of different agents. So actually the liquid freshwater fraction is less than 1% of all the water that's found on our planet. And water goes through a really incredible cycle as it changes states of matter from solid, liquid to gas, and that facilitates its movement across the planet. And we'll talk about that a bit more in a few slides. So winter comes on land. Many of us can see it outside our window right now in terms of its visual signs. Winter comes to the ocean too. Winter can cause the ocean to freeze and form sea ice. And also winter can just cool down the liquid water temperatures. So many large mammals, marine mammals and fish that remain active throughout wintertime will often migrate or transfer locations in order to find optimum feeding grounds. So for humpback whales, a really fun marine cetacean, they actually sort of go on a really incredibly long distance migration as they move between their sort of summer territories and their wintertime feeding grounds. And of course, one thing that they have at their advantage, and one sort of trend that we talked about a couple weeks ago that sort of does hold a bit true in aquatic systems as well, is that big organisms perform well in aquatic places that experience cold temperatures. So especially whales and seals and other marine mammals, they get by through a number of metabolic shifts, but the main ingredient that helps sort of see them through is fat, right? Is blubber. And that's a big difference that some of these animals put to advantage. And that's a big difference, for example, of birds, right? Birds can't create this sort of brown fat or blubber, so they have to get by. Even penguins, even though they look like they're fat, that's actually not fat. Those are very well designed feathers. So, but in many marine mammals' case, this insulation is sort of is the key to their survival. So you can see this not only in whales, but there's lots of other all across the trophic web, from primary consumers to all the way up to upper level predators that engage in these sort of long migrations throughout the year. So a bit about water, and stratification, which is a fancy way of saying layers, right? If you've ever gone swimming, especially in a lake in the summertime, you know that water forms layers based on temperature. And water has many cool attributes, most of which are conferred by its what we call polar molecules. The fact that each water molecule has a side of the molecule that's effectively a positive charge, and then the opposite side has a negative charge, and that leads to these incredible interactions between water molecules. And it's one of the things that makes ice float. So let's just talk about that for a minute. We can't take that for granted. Most liquids, when they freeze, they become more dense, and therefore they would sink. But water, when it freezes, becomes actually less dense than cold liquid water. So the curve that you see on the right is showing how water's density depends on temperature. And this is something that leads to all different manifestations throughout the biosphere. And many things we talk about today will sort of be predicated on the fact that ice floats. So ice, when it's at its maximum density, is when it's cold, a cold liquid, but not quite frozen. And as water approaches freezing, its density decreases and it floats. So this is why we get icebergs that float in the ocean, and why we get sea ice that floats in the ocean, and also ice lids that form on top of our rivers, lakes, and ponds in freshwater systems. And it also leads to really interesting dynamics in those aquatic systems. I think most of us humans, if we asked, which would you prefer, a cold water or warm water? Most of us would go with the warm. But actually, cold water retains a lot of dissolved ingredients that are essential to life. So many life forms that live in aquatic environments are actually quite attuned and adapted to living in cold water environments, because there's really big advantages to being able to tolerate those water strata. So I'll show you a figure that talks a bit about that in a minute. One thing I want to throw in there is that even though this is happening on a small scale in a lake, in a pond, even in a large river, it's also happening on a massive scale in the ocean. And this leads to what we call the Great Ocean Conveyor Belt. And it's one thing that connects all of the oceans of the world, right? So finally, this past year, the Southern Ocean, whoop, whoop, finally got officially on the map in terms of being considered a real ocean, as it should be. The Southern Ocean that surrounds Antarctica is actually the most diverse of any ocean because it's cold. So cold ocean leads to lots of dissolved oxygen, nutrient retention, and that helps foster higher levels of diversity. All right, so now I wanted to give a special shout out to the Californians that are out there. One interesting thing that happens on the West Coast that doesn't happen on the East Coast is upwelling. Upwelling happens when cold water, deep water currents, remember cold liquid water sinks, and when those cold liquid currents slam into the continents, those water strata are forced to the surface, and with it comes nutrient and oxygen abundance. And that's why we tend to see hyper diverse aquatic systems in these areas, even when the temperature is cold. So kelp forests, giant kelp, we see that in the Pacific Ocean at mid-latitude. We don't see that in the Atlantic Ocean at mid-latitude, primarily due to this difference in upwelling, as these cold, deep water currents are sort of forced to the surface. So it's a good thing to sort of keep in mind that cold water isn't necessarily a bad thing when it comes to organismal survival. And this graph is trying to drive home the point how dissolved oxygen, which is one of the most precious resources in aquatic environments, levels are higher when water temperature is lower. So dissolved oxygen sort of shown the profile shown in orange, and water temperature observations shown in blue. So you can see when water temperature rises, the dissolved oxygen decreases. And when the temperature suppresses, the oxygen, so colder water strata can literally hold more dissolved oxygen. And for heterotrophs, animals that rely on oxygen in order to carry out cellular respiration and go through their metabolism that's keeping them alive in these cold places, oxygen is going to be one of those key materials that they seek out and that they follow. Another dynamic feature of aquatic zones is the presence of ice. I just want to touch about this a bit. We'll talk about some critters that really depend on ice here in a bit. And ice, just like water, is diverse. You have lots of different types of ice. Some ice, like in continental Antarctica that we talked about a couple weeks ago, that ice comes from the compression of snow. Ice in aquatic environments comes from the freezing of the surface of the substrate. So remember, the ice will sort of accumulate there. So sea ice is a really interesting, habitat and also place of water storage on our planet. This figure is trying to show how sea ice dynamics change throughout the season, and also this is trying to show how there's been changes throughout the year. So this is Arctic sea ice. Here we're in the northern hemisphere, so that's why sea ice extent is high in our northern hemisphere winter months. Sea ice decreases annually with the onset of summer, reaches its minimum typically in the early part of fall, and then starts to rebound as we approach the next winter. One thing, of course, I'm sure you notice here is all the different lines. The different lines are different annual observations. So this figure is also trying to track the change in sea ice extent. And the most recent observation that it has on the graph here in pink, you can see that sea ice extent is decreasing. Climate change, it's real, and it's coming to an ocean near you. It's dramatically reshaping Arctic sea ice coverage in a way that's hard to overstate, that will likely see an ice-free Arctic conservatively within 50 years. So at least in the summertime, the sort of summertime minimum, this eventually within the next 50 years, as modeled by many scientists, this will sort of reach this level, this no sea ice in the summertime. Ocean water has a lot of salt content. That's what makes it the ocean after all. And one thing I'd like maybe folks to put in the chat, which would be fun if you wanna, is tell me where you think the salt in the ocean comes from. And in a little bit, and when I take a break, I'll look at some of those. So the salt ends up in the ocean, and that affects the freezing point of this aquatic substrate. So salts and different solutes, different materials that dissolve in water, decrease the freezing point depression. So ocean water actually doesn't freeze at 32 degrees Fahrenheit. It typically, although this can also vary, freezes at a lower temperature, typically around 28 degrees Fahrenheit. So entire oceans, and in fact, entire ecosystems depend on ice, especially in the Southern Ocean around Antarctica. This is krill. Krill is cool, right? Krill is these essentially, shrimp-like creatures that you can see, they're not totally microscopic, they're visible with the naked eye. And they are primary consumers. They're actually feeding on algae that is living underneath the sea ice. So krill depend on sea ice in order to feed themselves. And of course, many, many thousands of different species depend on krill, including most of the great baleen whales. This is their primary food source. So those humpbacks that we saw earlier, they've always been one of my faves, and this is their primary food source. So Antarctic krill, they sort of proliferate in the Antarctic, and then there's krill found in other places throughout the ocean, but in other times of their life cycle, they actually disperse quite widely throughout the ocean, but the nursery grounds of the krill is in this Antarctic zone. So if the Southern Ocean changes, then the oceans of the entire world change. So the world is really deeply connected in really interesting ways. All right, so now I'm looking at the some of the people thinking where salt comes from. Some really good guesses here. And in some ways, some of you are really right, more right than you might think. Like Emma says, it comes from rain. Not directly, but the rain falls on the continents and starts to weather a lot of the rock substrates and mineral substrates. That ends up in the river, and that ends up in the ocean. So I saw someone writing in rocks, and then also says, Christine wrote from runoff mountains, rivers into the oceans, right on. So one little grain at a time going from land into the ocean, and then the ocean becomes this repository of these salts. And to that end, are rivers and ponds and lakes salty? A little bit, but they don't have this, 4 billion year deposition like the ocean does. And when evaporation takes place, the salts get left behind. So the ocean is accumulating in its salt content over time. So the ocean is getting saltier. All right, cool. I'll take a halftime break here in a little bit once we maybe get out of Antarctica, okay? Look at this fish. This is an amazingly adapted fish. It might not look very special, but it's very special. It's a highly researched fish. Its name is a mouthful. It's the Antarctic notothenoid fish. Sometimes they're just called nototes because it's too long to say over and over again, right? So last time we were together and we talked about wood frogs, and we talked a bit about nematodes and how they make sugar molecules that help protect them from freezing in their tissues. So they create their biological antifreeze using sugar molecules. Most fish, and this is the best studied one and the one that produces the most of these, most fish, instead of sugar, they make proteins. When they experience cold temperatures, and in this organism, it's throughout its whole life, through other fish, they might do this on a seasonal basis, their primary cryoprotectant or freeze protection molecules are proteins or amino acids. So that's what's here shown as in this white here, these glycopeptides. That's something that, for example, this warm water perch doesn't have at all, doesn't have the capacity to sort of turn on the genes that make these protection molecules. So these are sort of specialized adaptations that not all fish have, but most fish have some capacity to make these glycopeptides if they experience cold temperatures. So a lot of the fish that live in lakes and ponds and rivers here in the Northeast, they are making some of these glycopeptides, maybe not quite as much as these Antarctic intimidating looking fish, but they are doing that a bit. So we can't leave Antarctica from talking about this critter, right? This is one that I talked too much about last time because it's hard to know where to put them. Are they aquatic? Are they terrestrial? They're kind of both. They're a bird with flappers, right? So, this bird is designed for water, and not only water, but also extremely punishing Antarctic winds. So you really have to give it up to the penguins, especially the emperor penguins. These are all dudes in this picture. These are the males that wait out the Antarctic winter in a huddle, and they can't eat, they can't really sleep. They are slowly just sort of moving in a circular fashion. And one of the most interesting parts of this is how they share the exterior, right? So these gentlemen here that are on the outside, they're getting the brunt of the wind and the ice, abrasion, but they actually rotate in a really sort of egalitarian, equitable fashion, which is remarkable, really, in terms of sort of this cooperation in order to survive. It's at the end, it's self-serving, right? If they try to do this on their own, they won't make it. So kind of like the snakes in the heap that we talked about last time in terms of using group heat in order to sort of help insulate each other. That's a really common thread that we see in lots of different taxa throughout nature in order sort of grouping together in order to weather really, really cold temperatures. All right, so this is a good time to maybe stop for a break in case there's any like pressing things anybody wants to talk about. Suzanne or anything?
I don't have anything pressing, but I did notice there were just 2 questions at the very beginning about whether you'd seen humpback whales or right whales.
I mean, I haven't been lucky to see too many right whales, and I honestly don't. I'm not located in a coastal location, unlike Suzanne. So it's been quite some time since I've seen them in person, but I'd love to. It's definitely on the list. And one little fun, does anybody know why it's called a right whale? Do they always swim with only the right fin? It's the right whale to hunt. So that's where they got their name. So whales are still, even though there's a moratorium on whaling in many parts of the world, it's not everywhere yet. So right whales are still, most whale populations are still of concern because of a lot of these sort of pressures.
Karen, there are a couple penguin related questions there. Where are the female penguins and how the males survive if they can't eat?
Yeah, I mean, the males are basically getting all along on, they don't really have traditional fat stores. So they store a lot of stuff in their crop, which is this kind of like pre-stomach. And then what they do is they sort of like every little bit, they sort of like extrude some of that to sort of keep themselves alive. And meanwhile, the females are off close to the coast where there's open water and the females are eating. And one thing I should mention is that those males in the huddle, they also have a penguin egg on their feet. So the whole time that they can't eat and they're stuck in a huddle, they also have their baby there. So the females are out at sea foraging wildly, and they will come ashore and greet the males about a month after the penguin chicks are born. And then the females will give the males a little bit to eat, feed the babies, and then the males are like, see you later, honey. The ocean calls me. And some penguin males don't simply make it to that point. They perish before that. They either because of exposure, they don't have enough of those that material stores and stuff like that. But it is amazing that really any of them survive. All right, so maybe I'll keep going, and if other people have questions, I'll try to leave some time at the end. So we'll talk about some other icy animals that I think you'll find interesting. One really interesting one is, thinking of other animals that depend on sea ice. This is, now we're in the northern hemisphere in the Arctic, sort of our polar places. Remember, penguins only in the Antarctic, polar bears only in the Arctic, and both places have seals, but they're different species of seals. So this is a really interesting sort of story of a seal where Arctic ring seals, this is a female and her offspring, her pup. She's given birth. You can see some blood in the snow. That's from her having her baby here. Nothing has, no predation has happened here. This is mom and this is baby. Baby's well camouflaged for living on the ice. And how they get along is quite amazing. Ring seals actually excavate an igloo-like structure, and inside is where they give birth. So, I think I get a little bit of beaver vibes when I look at this. It's a very different type of animal, but the structure that they make, totally different material. But if you've ever seen a cross section of a beaver mound, I'll show you in a little bit, it looks similar shape. So it's a very sort of bare bones, sort of open little structure, and it's protection because one of the ring seal's main predators, you might have heard of these folks, right? Well tuned to sort of find these ice lairs. So polar bears are another really, captivating, what I would call charismatic megafauna, right? There's just something about them that is undeniably awesome. Also really threatened by climate change. They're a supreme predator. What's really the only things that could take down a polar bear? Disease and a changing climate is pretty much it. So they are very sea ice dependent. It's the primary spot that they hunt from. And one of the main things that they're hunting for is some of these ring seals. They also will hunt for aquatic animals. So beluga whales, narwhals, seals that are swimming along, those sorts of animals. They will often lie in wait at one of like a breathing hole in between the sea ice and wait for their prey animal to approach. So with the changing climate means that polar bears have to swim a lot further between these sea ice hunting locations, and that really affects their ability to sort of have the nutrient reserves that they need, especially since a lot of the females are also looking after young ones. Okay, so we could talk about the ocean all day. So I'll maybe answer some questions about that in a bit. I wanted to also talk about lakes, ponds, and rivers a bit while we're together here, since some of you might be in coastal areas, but a lot of us are in sort of landlocked locations where the aquatic environments we're seeing are of freshwater variety, especially this time of year. So lakes and ponds are so interesting this time of year because their environment has changed so considerably to how it is throughout the other times of the year. Suddenly there's this cap on top, right? This ice lid, and the ice lid limits the penetration of light, and it also limits the gas exchange that would occur between the lake or pond water and the atmosphere. Most of the oxygen that's in lakes and ponds and the ocean, from that matter, comes from the atmosphere. The atmosphere is rich in oxygen. It's the second most abundant gas in our atmosphere. And because of fusion principles, whatever gases are in the atmosphere also dissolve in our aquatic environments. During wintertime, when an ice lid is present, that sort of gas exchange isn't prevented completely, but is definitely limited. So lakes, and this is showing you some cool lakes from here in New Hampshire. So if you guys are ever in this part of the world, definitely look me up. We'll go on a hike together. We get really great colors here in New Hampshire in the fall. This is a drone photo of one of the lakes that's protected. The entire shoreline of this whole lake is protected by the Harris Center. So we have it's a very shallow lake, as you can almost see by the amount of vegetation mats and algae that you see here. So as a lake goes from summer, fall to winter, lots of changes are happening and organisms are dying. So there's a lot of seasonal die-off of organisms. So this is a pond that I spend a lot of time at. It's a pond in the center of Hancock, close to the Harris Center. And in the summertime, I monitor cyanobacteria here, which is a microbe that are native, but they're of concern of late because some, but not all, cyanobacteria species produce toxins. So cyanobacteria toxicity is of concern in a lot of places right now. If you haven't heard about it in your area, I bet you, if you keep your ears pricked, you will soon. So a lot of the microbes that are in aquatic environments, if they are dependent on light, they are probably in a dormant state or have sort of completed their life cycle. And they're waiting for the sunshine to return. But meanwhile, life goes on for a lot of organisms underneath that ice lid. So we talked earlier about water stratification. That is most definitely a factor in lakes and ponds. And a really fun thing to think about is sort of in a lake right now, where is the water warmest? Well, actually at the bottom. In the summertime, lake water is warmest at the top because it's warmed by the sun. But in the wintertime, the sun can't penetrate. It's icy and cold up there. So in the wintertime, you actually get a situation where the warmest water strata are the lowest water strata. So where are the fish hanging out right now? Down there, pretty low. So if you're an ice fisher person, this is one of the things you have to monitor, sort of what are lake water strata temperatures doing, and then how is that affecting dissolved oxygen levels. So as winter disappears and we start to have the onset of spring, lakes and ponds will undergo this really important phenomena that happens generally about twice a year, where the water strata temperatures equilibrate, and that allows mixing of materials from the surface to the bottom and from the bottom to the surface. And that happens in the spring and the fall before this temperature-based stratification sets up. So right now, as we're sort of approaching sort of the last third of winter, a lot of the animals that live in these lakes and ponds, they're starting to be a little stressed for dissolved oxygen and also a lot of the other materials that they need, because they've been literally like sort of shunted off from a lot of the surface and a lot of the interactions that helped us to resupply those materials. So fish really have to contend with decreasing oxygen levels because there isn't really any replenishment coming from the atmosphere right now. If you're an aquatic mammal, you often have to boost your metabolism and forage really persistently in order to support that rapid metabolism. And aquatic reptiles and amphibians are often entering periods of dormancy, brumation, if you remember from last time. And many of them are actually doing that on the bottom of lakes and ponds and rivers. And they actually might still be able to absorb some of that oxygen through their skin or through different parts of their body. So here, this figure on the right is intending to show how oxygen changes with depth, right? As you increase depth, the amount of dissolved oxygen changes, and also so does the temperature. So many fish, as winter creeps on, they will enter higher strata of the water to sort of seek out these higher levels of oxygen that are present. Because remember, in the wintertime, that's where the cold water is. So you remember from before, cold water, lots of oxygen. In the wintertime, this is where the cold water is and the lots of oxygen. So fisher folks, this time of year, you can shorten your line, right? Because a lot of fish are inhabiting strata of the water that are just below the ice. And if you could peer through the ice, there might be snapping turtles, painted turtles, aquatic reptiles that are sort of in this, dormant state. They're in the water. They don't have to worry about freezing because the ice is going to float. They're protected from freezing, but they do have a suffocation danger, dangers posed by decreased oxygen levels. So they actually get by through using very sophisticated metabolic sort of shifts, sort of different levers that they turn on in their body that they don't sort of utilize in the summertime when they're active and food is abundant. So they use anaerobic respiration, which is respiration that proceeds without the need for oxygen. And they also undergo a process of glycolysis, which is how they can actually generate energy molecules and oxygen from stored materials within their body. So pretty amazing adaptations. So since they're cold-blooded, the fancy term for that is poikilotherms, right? Since aquatic reptiles and amphibians are cold-blooded, coping with suppressed body temperatures, again, not a really big thing for them. So it's mostly about how do they metabolize their food stores without abundant oxygen, but they have figured out how to do that by cleaving glucose molecules through a slightly different metabolic process. So, and if you've ever heard of lactic acid is a material that if not dealt with can be fatal to a lot of organisms. So turtles also have mechanisms to deal with the lactic acid that builds up through this glycolysis process. So next time you see a turtle, they're remarkable for all sorts of reasons, internally, as well as how awesome they look in their physical appearance. Okay, just a couple more here. Beavers, Beavers are another amazing winter active animal. And, you know, they spend some time on land, but they're really designed to swim. So beavers have to make a cache in the fall. And what they do is they basically sort of stick branches into the muck around their lodge. And they don't hibernate, they stay active all winter. They actually make their exit hole to their lodge below the ice, and they can actually like enter and exit their lodge and then sort of reside in this area. And they stay quite insulated in there, especially when the snow falls on top of the lodge. Snow is just an incredible insulator. So they're quite toasty in there, especially considering that they can store tons of fat, not only in their furry body, but also in their tail. So they have massive fat stores, but they also need to forage really persistently in order to have enough food to survive. So if you ever wonder whether or not a beaver lodge is active or not, if you look around the lodge and you see small trees, saplings, branches that are sort of stuck into the sediments around the lodge, if they still have leaves on them or they look recently stored there, then that's an active lodge. And if you stay and wait long enough, especially early in the morning, you might see the beavers leaving. And the one thing they also have to do is they have to keep the area around their lodge ice free, and that requires them to sort of stay active. So they're always out there. Beavers, the busy beaver, they stay true to the adage, not only during the summer, but also during the winter too. And then otters. So this is a river otter. Sea otters, also awesome. All otters have really incredible fur. Sea otters especially. They have the most specialized fur of any animal. River otters are the critter that we see of any otter here in New Hampshire. And they're a winter active mammal. And this time of year, this is a picture that's taken by a local fellow. And this is a river otter slide. So they slide on their belly. They would rather get around that way. They will walk if they have to, but they'd rather slide. Why not, right? They're really adept predators. And those sleepy turtles that we talked about earlier, they're the river otter's favorite wintertime foods. So they can sort of feast with wild abandon in a lot of these aquatic systems because many of the organisms there are either in a sort of, dormant state or a little bit sluggish due to cold temperatures. All right, and a quick bit about rivers. Rivers in winter are very dynamic, as they always are. And they form really interesting types of ice because they're turbulent and they're turning the water over. So if you watch a river in winter, you see these plates come from the sides as the surface water freezes. But then if you watch the flowing water, if conditions are right, the river water will partially freeze at the surface where it almost looks like a giant Slurpee machine. And that's what we call frazzle ice. And frazzle ice, it's hard to describe what it really is. It's like a mix between like snow, slush, ice. It's Slurpee. It's coming down the river. And it makes it difficult for a lot of aquatic organisms to navigate that. But frazzle ice is usually pretty temporary. Conditions have to be right for it to form. Where river dynamics get really interesting is there's also what we call anchor ice, which is ice that forms at the bottom of the river because the frazzle ice gets sort of stuck on river rocks. When the anchor ice starts to form, ice begets ice. The ice crystals start to collect each other And in that situation, you can get a river that actually can freeze solid. That situation does not happen all that often. If you watch even a small stream, the act of the flowing turbulent water, that really prevents that sort of full scale freezing that happens. But river living is really difficult. Most organisms that are residing in rivers throughout the winter are not active. They're just sort of hanging on for warmer times. So it's definitely an interesting system to watch, but one that's really difficult for organisms to survive in. So many river fish, again, if the river's deep enough, they will often inhabit sort of lower strata of the river. If the river is really shallow, it can mean that organisms need to seek out other environments because surviving there might be impossible throughout the most lowest temperature times of the year. All right, I have a few minutes for questions, but I want to say thanks so much for coming today, and thanks so much to everybody at the Wells Reserve, especially Suzanne for inviting me. So thanks so much for listening, and if you ever want to follow up with me, I put my name in the chat and email in the chat there.
Thank you, Karen. I know we do have a whole bunch of questions. There were a few left over from the penguin time. Sea snakes. Do the sea snakes live where water gets cold, and how do they survive? And then do penguins mate for life?
Okay, yeah, I mean, sea snakes are typically more tropical. So the land of the sea snake is primarily like Australia, Thailand, sort of the archipelagos in Asia. They have a lot of like sea snakes. So they're more snakes that would not have, like cold tolerance mechanisms. Do penguins mate for life? Yeah, they do. But if one of their mates dies, then they will find another. And the amazing thing is when those females come back from foraging, they find each other by a song, like they honk at each other, and sounds all the same to me, but the song is individual enough that they can find their mate just based on singing. And if you've ever seen videos of that, of the reunited and it feels so good moment, it's pretty remarkable. I don't know how these animals do it. It's amazing. They do all sorts of things that we can't do. And granted, we can do things that they can't do, but it's really interesting how it all shakes out. Okay, why do beavers chew the bark entirely from around a large tree? Well, they often, if it's a large tree, they don't want that tree there. If they're doing it on a large tree, it's because they want to kill that tree. So they'll often girdle it, they'll chew it all the way around. That kills the tree, and they'll wait for a windstorm to blow it on over. If it's a small tree, they probably want to eat it. So if you've ever seen like the very pointy evidence of a beaver chew little sapling, the saplings, they're literally moving back to their stream side or river or pond side habitat, and then they're either eating it right away or maybe they're saving it for later. And parent beavers, they have to bring food back for their young beavers, so it's beaver takeout. Are beavers herbivores? Yes, they are. 100% herbivorous. And pretty much the only thing they eat, their favorite food, they'll eat leaves, but it's kind of like means to an end. What they really want is the cambium, which is the kind of corky, gummy tissue that's right underneath the bark. That's their food source. So even though they're swimming in a pond and they could eat frogs, Nope. Tree only.
Karen, I just noticed a question further up. How much krill can a whale eat?
Oh gosh, I don't know. I'd have to look up, but it would be a fantastic amount. So when you think about that, of like, it's part of the reason why, large organisms aren't super abundant in the world, even before humans started changing the biodiversity picture, right? That large organisms need massive amounts of food support. So, on a day, hundreds of pounds of krill is, I think, a safe estimate for a daily diet. And then think about it, that's just for one whale. So to support whole populations, you need a lot, and you need the krill in the right spot at the right time. So that's another troubling thing we're starting to see, is a dysynchronicity, right? Where the krill might bloom at a time where the humpbacks aren't present in Antarctica to really feast upon that. And if that happens, then systems start to kind of get disjointed a bit. So, it's great to hear so much care for cold critters. And another C word that I would implore you to care about is carbon, because keeping an eye on carbon and decreasing carbon emissions where appropriate is one of the key things that you can do to keep cold places cold and cold critters happy. Dominic asked earlier, what causes temperature to rise in water? Mostly the sun. The sun is the main agent of water warming. And then that'll cause that water to float. And then, so we see, sort of dynamics and just sort of the temperature of a lake when the sun is up versus when the sun is down, even over just a 24-hour period. So the sun really makes a lot of that happen.
There was also a question about how long it takes the sun to melt ice, I think. Let's see. Yeah, how long does it take the sun to melt the ice?
Well, it depends on thickness. Like right now, here in New Hampshire, people are starting to drive their vehicles on top of the ice, which always seems like a big old leap of faith to me. But I would say here in New Hampshire, again, it depends. It depends on if the ponds have an inflow or an outflow and how big those are. But I would say conservatively, the ice here in New Hampshire is probably about 2 feet thick right now. So that it's not an overnight thing, where ice in can almost happen like whoop, you don't look and then you look and then it's there. The ice out is often it takes, even if you get a really swift warm up, if it's when the ice is thick like this, it would still take a few days.
Karen, you froze for us. Well, while she's unfreezing, just wanted to let you all know that we do have another Lunch and Learn coming up. It won't be with Karen, but it's with a Maine herpetologist who studies reptiles, and he'll be doing a program on snakes of Maine. And that is, I believe, February 9th. You can check www.wellsreserve.org. That's where our calendar is of all of our programs coming up. And we'll also have a bear program in March and a lynx program in March. So lots of wildlife programming coming to Zoom via the Wells Reserve. I think we lost our presenter, Karen. So I will share with her all these wonderful comments in the chat box. And thank you to Molly, who checked the internet and found out that blue whales eat 3.5 to 4 tons of krill per day. So thank you, Molly. And here's another comment. Dublin Lake sometimes takes till May to unfreeze. Yes. Thanks, Karen.